In the previous tutorial, we were talking about how we were using derivatives to find local significant changes that will help us to identify edges in images. And for that, we found some numerical approximation of the partial derivatives on direction of x and the direction of y. And, um, and what I said in this topic, there will be different ways of interpreting how those local changes can be identified. So the one that we did was a very simple example that we would see that actually works. But also we can also talk about what is the gradient of a function of two variables, which in the two-dimensional is the two-dimensional equivalent of the first derivative. So this is basically a vector of a function that is composed by the first derivative, the derivative in the direction of x and the derivative on the direction of y. So here it is an example of a function, and like in the previous tutorial we were talking about how do we compute the derivatives. In the previous tutorial I was talking about using the definition, but also we can just apply formula. So here is that the partial derivative on the x will be, yes, x is the one that changes, anything else is constant. So in this case the 2 multiplies the 4 is going to be ax, and the y squared remains the same, and then here is 3xy to the 5, so it's 3y5, and then I don't think you see on the screen is plus 6 over there, but you had the notes in the content section. So we do the same with the partial derivative of y, and then so in that case the y is the one that changes, so we follow the same procedure. And anything that is not a y is constant, so 2 times 4 will be 8, the x squared remains constant, and then here the y to the power of 5, so we multiply 5 times 3, that's 15, and then 5 minus 1 will be 4, so it's 15, the x remains the same because it's constant, y to the power of 4, and then the plus 6, that will be equals to 0. So that gets the gradient, which is this vector. Now how's that going to be useful if we're talking about images? So remember that the x and the y represents a position in the image, and in general for a function, I mean, if we just substitute the gradient on, in this case 4, negative 3, we just do the substitution of x and y, and then we get the vector that I think, if I got my computations right here, is negative 917 and 4076, and if I do it on 1, it will be 11,23. So now you see by examining the gradient that may be something useful in identifying edges too, because then I can have several vectors on different locations in the region, which in this case will be the image, and in this vector gonna be pointing to the direction of the max change, which is in this case our edges. And then we can also work with what we call the isotropic operators with the vector, because a vector is going to have a direction and a magnitude, so and it's going to be pointing to the direction of the maximum rate of change. So in this case here the angle is that direction, and the double bar is the magnitude, which is in this case is how far. So you can interpret this like using the Pythagorean theorem, or and this is how we can compute the angle, and this is how we compute the magnitude. So we're doing approximations, like computing this for every pixel is going to be what we call computational expensive. It's going to allow computation, so we got again approximations of the magnitude of the gradient by doing the addition of the absolute value or the max of x, comma y. So to end all this theory, we just want to practice some exercises in Scilab. So for that I'm asking that we define this mask that for the filters. Remember that in the previous tutorial we identified that if we can do the convolution using the mask or the kernel -1 and 1 and 1 comma -1 as indicated here in the direction of x and the direction of y. We can do the approximation of the first derivatives. I mean the approximation on the partial derivative on the direction of x and the direction of y. Okay, so for this lab assignment, what we will do is that we will define these variables fx and fy, and we're going to load an image, and we will try to find basically the image, the edges on the image. So here are the steps. So step number 1, you need to get an image on your own. I think you know how to do that, and we're calling that image A. And then as an optional case, since we do filtering, you can do some filtering that sometimes is recommended to get rid of noise. We don't have to do that. And we can practice filtering in different ways, like doing this. And then I can say also that maybe 4 can be also optional. I'm doing some thresholding to see better results on the image. So I will show some results of performing these experiments. So on my Scilab, I have already my variable A. So I will show you the image. Image show A. So I think you can see this image. So that's my image A. So we want to find some edges. So for that, I'm asking you to define the fx. So this is the way that you do the definition, the fy with the mask, and then we need to do the convolution, right? So we're gonna do image show, and I did that already. So here, for example, in this statement, we're doing the convolution on the image A, and then we're gonna see the results. So look how nice it looks. Then I think you can do even more experiments. So in my case, this is still a RGB image. I didn't do the grayscale, but you can notice the edges there. But just doing, in this case, an examination of the changes of the partial derivative on the direction of x. Now we can do the same experiment with fy. What about the changes on the direction of y? And then I get another result. So this is the type of experiments that I want you to work on it and see. There will be, there is not just one unique way of getting the edges of the image. Like for example, in this case, I'm using those derivatives. But if you see on the assignment, I say, well, what about if you do this type of ideas? Like, I didn't, for example, do the absolute value, which will be the performing the abs function, ABS function on that. So here is, maybe I can do the absolute value. Maybe I can get an image that I'm combining the direction of x and y. What about if I have a black and white, a grayscale image or a black and white image, and then I do thresholding on the image? What about if I combine that with filtering? So at least do something like the one that I did with the fx, fy, but I want you to practice some experiments on exploring edges on images.